Hello friends, welcome to the channel. My name is Pedram. I'm an IC designer, and today we want to take a look at this amazing electronic engineering mind map. Alright, the app that I am using is called Mindmap. It's an app that's generally used for making mind map, but it's also used for other stuff. As you can see, the form is like this. There's a chat room in this site, that also the link in the description, that you can chat in the left side, and the main explanation of the mind map is at the right side. You can check them out. Okay, the way it works is you just write everything and connect to each other, and there are some cards in it that if you click on this expand button, you can see what's in it. There you go. This is all of my social media. Don't forget to follow me in there. What I want to do here is to mention all the fields in electrical engineering and link them to the experts that are in this field. If you want to quickly take a look at it, we have the roadmap of what we should learn. We have the necessary softwares. We have some other skills that we should learn aside what we are doing in our academic endeavor, and we have some potential futures and some experts in this field. And I should say this is not the first version that I'm making. It's been about 6 months that I've been working on this mindmap, and the initial version was something like this. All I wanted to say was just to how to do analog designing with an OpAmp, but I make this make that bigger, and it became something that we will check it out now. Okay, electrical engineering fields. Basically, the electrical engineering fields consist of 4 main fields: power system, communication system, control system, and electronics. But there are some other fields that are included in that can be included in electrical engineering field. That can be in power electronics, which is an interdisciplinary field between power system and electronics. Biomedical engineering, some universities has this as a part of the electrical engineering program, but some of them has their own faculty, their own building, and everything is separated from electrical engineering, but it's really related to this topic. The other one is neuroscience. It's a very small university, very small amount of university has this field, and it can be a part of electrical engineering because it's highly related to control engineering, because people in control engineering, control systems, basically what they do is to model different systems, and if those systems are our neurons in our brain, then they are doing some neuroscience and stuff. Yeah, okay. I obviously don't want to talk about all of these fields because I basically can't. It's impossible. Maybe if some of you are interested in this, definitely hit me up. I will be happy to do a collaboration with you. But the part that I want to talk about is a small proportion of electronic engineering. All right, electronic engineering basically it's a classification that I've done here, and obviously the main field that I've chosen is IC designing. Discrete design is tightly related to IC designing. Most of the rules can be applied in both fields, but discrete design has some its own niche topics, if I want to say. We have hardware design language, HDL, which is basically programming, but you are programming, instead of programming software, you're programming different gates that they are connected, and they can be big, very large circuits. They can also be small, but most of the time they are used for large circuits. You have microcontrollers programming and device physics. All of these can be a part of electrical engineering. All right, IC designing. IC designing has its own fields, but it can be highly interdisciplinary with medicine, biomedical engineering, and neuroscience, which is actually the field that I'm interested. I'm gonna save that part for the next video, but for now I'm just want to talk about pure electronic and what we learn in IC design. All right, first of all, we have analog designing. Analog designing basically has two fields. One of them is classical and the other one is bioelectronic circuits. The classical is the same good old OpAmp designing. We have another field called digital. These are not necessarily digital. These are the topics that we should know in this field before choosing our special field. But if you continue each one of them, you can be specialties in that field. We have digital field. In digital field, basically people what to do is to do memory designing, system designing, microprocessors, microcontrollers, SOC, SIP, POP, and so on. The difference between these are explained in this link. There's a website in there that you can study them. Just click here and you can see the link to that page. And we have hardware security. Hardware security, because you see the security name in it, it doesn't mean that someone's gonna hack this. Yes, there are some security measurements that will be done when they are designing some specific ICs, but hardware security in here is basically focusing on after fabrication, after we build these ICs, are there what we want to be or not? Basically is one of the reliabilities of the logical circuits that we design. All right, next part is the filter designing. Basically these are filters. They can filter signals after a specific signal. We have RFIC, radio frequency integrated circuits, and we have its own niche topics. They are basically the transmitter and receivers on your phone and other digital devices. We have optical electronics, which I should say something before going to optical electronics, is the classification of these circuits, this type of circuits is mainly done by the range of frequencies that they are operating on. If you are working on the high frequencies, for example, up to these days up to 300 gigahertz, they are classified as the RFIC. But after that, circuits cannot work in a way that they used to be, that we classically study them. So some other techniques will be applied on them, and they will be studied in optical electronic fields. Optical electronic fields mainly consist of trials application. And if you click here, there is a YouTube video in here that you can watch it, and professor will explain it very well. The main applications are here. We have mixed signal design, which are ADC, analog to digital converter, digital to analog converters, sample and hold circuits, and DC-DC converters. We have layout of them, and we have MEMS, macro electromechanical system. This is a field that is interdisciplinary between mechanical engineering and electronic engineering. So many good applications can be done with this. I don't know so much about this, but I really love to know. I will put more information about this field in the future in this part. All right, these are the main fields in electronic engineering that I made a playlist about all of them on my YouTube channel that you can check them out here. One of them is neuromorphic, PCB designing, fabrication, RFIC, optical electronic, and in the future more video will be added to this part, more playlists and more video that you can watch them. You might say, okay, my university will always give me a roadmap of what I should study. What's the difference of these between what my university gave me? I should say that your university never advertised the professor from other universities and other best universities. They hardly do it. Maybe they have some contract with other universities, but most of the time they don't. What I'm doing here is I want to gather information from the best of these, the best of the best in this Mindmap. The link to the best of the best from each section that you can take a look at it. Okay, these are the different fields, but we have something here that I call it tree of knowledge. If we zoom out a bit, you can see that it is like a tree, and this is a trunk of it, and these are the knowledge that you should know before moving to any special field. And there's also essential softwares that I will talk about them later. And yeah, these are the list of the courses that you should pass. I feel like it's completed, but if it's not, I will finish it later on. And we have a technology node here. There are some workshops in here that they will talk about the technology nodes in electrical engineering. As we already know, we are currently on 5 nanometer technology for our metal oxide semiconductor devices and transistors. What I mean, we have different fabrication manufacturers. This is still a work in progress. I will finish these parts. These are just, I have some ideas about. All right. Okay. First of all, we have prerequisites. I'm not going to take time on explaining this part, but whatever we need, we will explain them in the required place. We have circuit analysis. This is basically the basic of the circuits. I will finish this part. This is still a work in progress, but for now I have my focus on analog circuits. They are here. They are not completed. None of them are completed. I will finish them as I am making video about each one of them. So, because the knowledge is built on the shoulder of the giants, the big brains, what I want to do, I will choose an online course and I will make my mind map, my explanation based on their explanation. I will add more from other books. As you can see, there are some reference book about analog design here. The best one of them, there's a professor in Caltech. He is Ali Hajmiri. His book is amazing. He also has some online courses. His specialties is in RFIC. By the way, we have a section called Big Brains. You can check them out here. And his courses are here. Electron Course. These two courses are his circuit design and his analog design. What I want to do is to summarize all of his lecture, and while I'm summarizing them, I will add more example to what he taught in his courses. I also made a digital handout in OneNote that I will make them available. I have two OneNote handouts. I will extensively talk about them later on, but one of them is basically whatever I will talk about in here, and the other one is my personal analog handout that I have those informations in them. His handbook, his book is amazing, but it is still on work in progress and it's not finished. And after noise part, it has nothing in there, but I saw most of his lectures and I have a handout of those that I will talk about them later on. Let's show it right now. All right, as you can see, this is OneNote, and this is the handout that I will share it. All you need to do is just click the link down into the description, and all the sections are available here, and all the lecture are here. Most of them are not organized like this, but eventually they will be organized like this. I'm still working on them, but after I organize each one of them, I will make a good explanation about every single one of these parts in a quick time. All right, back to the mind map. Okay, so far what we do is to refer ourselves to some of the best courses in the world, summarize them, and add more stuff from other book. Okay, and in this way we can be an expert in that field. And after doing this for analog design, I will, instead of going to digital design, I will jump into OpAmp designing. I'm currently making an OpAmp designing course myself, gathering all this information together and just explaining the OpAmp designing part. So after we studied all the analog electronic, we will just practically study these with the practical application, which I'm using Cadence IC software. By the way, these are the softwares that you can find in electronic engineering, simulation part, CAD tools, Cadence IC, and I will extensively talk about Cadence IC and what we can do in schematic, block diagram, and hopefully in the future about the layout. All right, these are other tools. It's good to know them because you obviously need to know about them, because you should know that we can do these works. For example, we can do some special works with Altium Designer, and you should just know that there's a tool called Altium Designer. For example, in case you someday need to do something with it. Okay, we have MATLAB, we have microcontrollers programming. You can go through them and take a look at them all. But I highly recommend you that to watch some of the videos about Mendeley, how to use Mendeley. I've linked from some of the professor in this field that you can check them out. They're explaining really good about these fields. And yeah, and we will also talk about the digital note-taking apps and some of the tips and tricks that you can use them later on. All right. After digital design, we have these parts that they are still in work in progress. I will finish them all later on. We have mixed signal, we have the reference book at the left side, and in the future, after I finish them, all of them will be color coded. So feel free to leave your comments here in the left side. There are some works after you design these circuits. You should test them. They are called test bench. It's a really advanced one. Usually people in their PhD need to design, they must design a circuit, and hopefully in the future I will finish this part. All right. Studying in an academic career is not all about just studying. Most of it is about writing in English. Yeah. And if your English is not good, it's okay. I have so many materials in here. I have dedicated places on my YouTube channel, dedicated playlists about academic writing and stuff like that. And there are a list of YouTube channels that you can use them. They are not somehow here, but let me fix it. There we go. It is fixed. Definitely subscribe to all of these if you want to learn English really well, and you obviously need to learn writing. Don't worry, people in university don't know how to write. It's not a shame to not know how to write. It's actually okay. If you want to know, definitely I highly recommend you to watch these workshops. They are amazing. These are the link to some websites that you can check them out. And while you are learning how to write, you should also know about the communities in your field. Here is a weblog. There are some weblogs for electronic engineering that you should check them out. These are different publishers, and obviously all of you, I'm sure that you know, are familiar with IEEE. If you want, you can find your community, your favorite community here. But just click here. There's a link to its website that you can find the related communities. This is Roadmap community. You can check them out. These are different publishers. We have Springer, and there's a really good tool with the Springer. If you click on this link, it's a website. Just open it with Chrome. It's currently not working with other browsers. You can use it. You can give your article to it, and it will fix the template that you need to publish your work with it. It's a really useful website. There is another website from the Relay publisher that if you submit your abstract, it will recommend you the most suitable journal that you can publish your paper in it. But it's just from that Relay journal. You have, of course, IEEE, its journal, its conferences. I will leave a link to down these conferences, and when they are about to be started or you need to attend to them, I will usually repost those links in my Twitter account. Definitely follow me in there. There's so many good stuff. And we have, of course, Nature, the best journal, I think, I believe, which is. And they have a Twitter account that you can check them out, and they will post some hot topics in there. Okay, we have some different issues from the journals. I don't think I'm gonna finish this part because there are so many issues in these journals. So maybe. But the best part, or the most important part, is these type of writings that you should know. We have conference paper, journal papers, we have dissertation, we have literature review writing, which can be a part of your dissertation and your papers, and we have patents. I recently learned something really cool about patents. Unlike journal papers, which are not classified in a group, patents are classified. So yeah, I will extensively talk about the patents. If you do, it doesn't matter if you want to do a patent or not. There are so many good classifications there that we all need to use them. I will apply those classification on this map definitely in the future. All right, these are the different fields. Obviously, haven't talked about them extensively because obviously cannot. If you want to know about them, I will leave a link to some of them. These are the big brains, of course, in different fields. Check them out. I will add more people here. If you know more people about other fields, definitely let me know. Preferably comment down here in the left side so we can all chat together. And my main field, the field that I am working and the field that I am interested to work is brain-machine interface devices. Let's leave that one for the next video. Alright, with that being said, I want you all to have an amazing day. Don't forget to smile, and I will see you in the next video. The link is up here, and enjoy the rest of your day.